Okay, so what if I told you that we could use something as cool as virtual reality to tackle one of the biggest challenges we're facing today? I'm talking about the cognitive effects of aging. Well, that's exactly the big idea behind the Geriatric Project. It's this incredible effort to not just assess, but also train the aging brain.
Now, before we dive into all the high-tech stuff, we really need to understand the problem they're solving. Because, this isn't some abstract issue. It's a quiet struggle, one that's happening every single day in homes all across Europe, where millions are dealing with the challenges of cognitive decline.
And the sheer scale of this is, well, it's kind of mind-blowing. Right now, 1 in every 5 people in Europe is over the age of 65. Just let that sink in. That's a huge, huge part of the population that's navigating the tough realities that come with getting older.
So what does that struggle actually look like, day to day? It's really about the slow creep of losing your independence. We're talking about things that experts have a fancy name for, instrumental activities of daily living, or IADLs. But really, it's the simple stuff, the things we take for granted, like managing your finances, doing the grocery shopping, or even just remembering to take your medication. These things can turn into huge, monumental challenges.
And here's the thing. Early detection is absolutely key. The sooner we can spot any cognitive decline, the more we can do to help. But, and this is a big but, the tools we've been relying on, they're failing. They're just not cutting it anymore. And this gets to the fundamental flaw in how we've been doing things. Think about it. When we sit an older adult down in front of a standard computer for a test, are we really measuring their cognitive ability, or are we just testing how good they are with a mouse and keyboard? All too often, it's the second one. And that can lead to what's called a false positive, basically a misdiagnosis. Someone gets flagged for a cognitive issue that they don't even have, just because they're not comfortable with the tech. And this is where you can really see the genius of the Geriatric Project. It's filling a massive gap. So on one hand, you've got the old way. These tests are clunky, they're tough for anyone with motor issues, and here's the kicker. They have what scientists call low ecological validity. That's a fancy way of saying they have almost nothing to do with real life. But then you look at the geriatric approach. It's intuitive, it's accessible, and it's built to simulate the actual daily tasks that people struggle with. The whole point is to get much, much more precise and meaningful data.
So that's the gap. And this is the solution. The Geriatric Project isn't just about making a slightly better test. No, it's a completely different way of thinking, and it's all built around immersive virtual reality.
And you gotta love the name, right? It's a fantastic acronym. Geriatric actually stands for, take a deep breath, gaze and hand interactions for enhancing usability and accessibility of virtual reality applications in neuropsychology. Whew. But it's brilliant because it lays out the entire mission right there in the name. It's all about using our most natural tools, our hands and our eyes, to make VR a truly accessible way to assess cognition.
And hey, don't just take my word for it. Here it is, straight from the project proposal. The whole idea is to use immersive VR to simulate real-life conditions, to create a test that actually shows how a person can function in their day-to-day world. It's all about bridging that huge gap between what happens in a doctor's office and what happens in real life. Now, a project this big, this ambitious, you need a real powerhouse team to pull it off. And that's exactly what they have. You've got the academic brainpower from the University of Athens, the deep research skills of the Athena Research Center, and the commercial smarts of a company called NeoAura. It's this perfect mix of science and industry, and it's all backed by some serious funding from the EU's Horizon Europe program. Pretty impressive. Okay, so we get the what and the why, but what about the how? How does this technology actually work? I mean, how do you make virtual reality so easy to use that literally anyone, no matter their tech skills or physical limits, can just jump right in? Well, the whole system is built on 3 key pillars. First up is Immersive Virtual Reality, or IVR. This is what creates that super realistic 360-degree world. Then you've got finger tracking. This is huge. It means you can use your own hands to interact with things, no clunky controllers. And third, eye tracking. Honestly, this is a total game changer for accessibility because it lets you interact with the world just by looking at things. So what's the goal here? It's simple, really. To create an assessment that's so intuitive, there's zero confusion. No buttons to press, no keyboards to type on. You just use what you've been using your whole life, your hands and your eyes. It's all about making the technology feel completely invisible. And you can see how each piece of tech has a crystal clear job.
The finger tracking, that's all about usability, letting you just reach out and grab things. The eye tracking, that's for accessibility, opening this up to so many more people. And the immersive VR itself, that's what gives it real clinical value, because it's simulating the real world. The project itself follows a really smart, clear path. It all kicks off with the heavy-duty tech development, building the prototypes for the finger and eye tracking. Then, it moves into the crucial research phase, testing it out with both younger and older adults to make sure it works. And finally, the whole thing gets handed off to the commercial side to transform it from a research tool into something you could actually buy and use for training. It's that classic from lab to life journey. And that transition from the lab to real life brings us to the really big picture here. Because the impact of a project like this goes way, way beyond just the research. We're talking about something that could genuinely change lives and even reshape the future of digital health. And when you zoom out, the potential impact is just massive. On the science side, this could set a brand new standard for cognitive assessment. For society, it could mean more independence and a better quality of life for our older population, which is huge. And economically, it could help lower the staggering cost of elderly care, and at the same time, spark a ton of innovation in Europe's digital health scene. And this is a really important point. The project's ambition doesn't end with just testing people. That's only half the story. The ultimate goal is to turn this into a powerful training platform. See, it's not just about finding a problem. It's about giving people a tool to actively work on and improve their cognitive skills. And here's something that I think is just fantastic. The team is totally committed to open science. Their plan is to make the tools they build, the software, the code, everything, free and open source for other researchers and clinicians. So this isn't just about their own success. It's about lifting up the entire field and letting everyone build on what they've started. So it really leaves you with a pretty wild thought, doesn't it? The geriatric project shows that by making technology more human, more intuitive, and more connected to our real lives, the answer to one of our biggest real-world challenges might just be waiting for us, inside a virtual one.